Hey everybody, welcome. Today 2.2 is coming your way. We're going to be talking about comparing and ordering rational numbers. In the last video we discussed what a rational number is. Today we're going to be comparing and ordering them. Here we go. Alright, so the very first thing is we're going to write each fraction as a decimal. We're going to be doing this during the lesson today. So get ready for that. So please write each fraction as a decimal. Even if you memorize them, you can just write them down. All right. Here we go. 1/3. Remember, as we take this, we take 3 into 1. How many times is 3 going to 1? We can't do it. So then we put a point in our decimal point and then a 0. Then we take 3 into 10. And our answer is going to be 0.3 repeating. 0.3 repeating. 4/5. 4/5 are just 4 times 1/5. 4/5 is 0.8. Again, take 5 into 4. 3/4. 0.75. 0.75. And the last one, 2/3 is just 1/3 times 2, so you just take, if you know 1/3, you also know 2/3. So 2/3, 0.6, again, it is repeating. Okay, so we're going to be talking about this a little bit today and how to compare. So if you look at this, today we're going to be learning about comparing and ordering positive and negative rational numbers. So they're going to be written as fractions, they're going to be written as decimals, integers, all the above. Okay, they're going to be, some are going to be positive, some are going to be negative. Get used to seeing positive and negative numbers because you will see them from now on. All right. The first thing I want you to do is write down LCD. Alright, so if you look at LCD, or least common denominator, okay, is the common multiple of the denominators. You can use this to find a common denominator that's the smallest number in order to compare two fractions. Because when we compare two fractions, we are going to have a common denominator. Alright? So if you look at this, we will be comparing things using least common denominator or something else. So if you can just write this down, and I will explain in just a moment. So pause now, write this down, and I will explain. Alright, so if you look at this, we are going to be comparing these numbers. So we're going to be comparing 5 and 2/9 and 5 and 2/7. And then we will compare negative 0.44 and a negative 2/5. So when we compare 5 and 2/9 and 5 and 2/7, the very first thing I look at is these whole numbers. If the whole numbers are the same, then I start looking at the fractions. Okay. If the whole numbers are the same, then I look at the fractions. If they're not the same, okay. So for instance, if I give you 5 and 2/9 and 6 and 2/9, well, or 6 and 2/7, I don't have to look at anything other than this 6. That 6 is automatically going to be bigger than the 5, so that 6 and 2/7 would be larger. However, we have 5 and 2/9 and 5 and 2/7, so what I'm going to do is I'm going to compare 2/9 and 2/7. So how I do that, okay, I like to find a common denominator. The easiest way to find a common denominator is just to take, and you can do it multiple ways, but if you just take 9 times 7 and you get 63, okay, so a common denominator of 63, then whatever you multiply the denominators by, you have to multiply the numerators by. Remember, we are not finding this in simplest form. All we are doing is finding which one's bigger or not. So 2 times 7, 14, 2 times 9, 18. Since 18 is larger than 14, 5 and 2/7 is larger. So 5 and 2/9 is less than 5 and 2/7. Alright? I go through those same motions when I compare two fractions. Now, I'm comparing a decimal and a fraction. So what do? Well, I convert either the decimal into a fraction or I convert the fraction into the decimal. In my mind, it's going to be quicker to convert this negative 2/5. Okay, so I'm going to convert that fraction into a decimal. Now, if you think it's quicker to convert the negative 444 into a fraction, do that. Absolutely do that. Okay, whichever works for you, do that problem. Okay, so I'm going to convert negative 2/5 into a decimal, and when I do, I take 5 into 2. How many times 5 go into 2? Can't do it, so I put my decimal, plug a 0 in. 5 into 20 is 4. I get a remainder of 0, but remember, I'm taking a negative divided by a positive. My answer is negative, so now I'm looking at negative 0.44 and a negative 0.4. So which one is larger? Well, remember, behind this 4 is an infinite number of zeros. So if I look at that, this 4 is larger than this 0. Okay, so negative 0.44 is farther to the left than negative 0.40. So again, we have our less than symbol. Okay, less than symbol. All right, and now be careful. Ooh, I almost forgot to explain it. Okay, don't forget that it is negative. It's negative, so that negative 0.44 is farther to the left of 0, which means we have to use our number line. Okay. All right, so now we have a 1/9 and 0.1. Same idea. You don't have to write this down, but if I look at this, how would I compare these two fractions, or these two numbers? Well, I'd have to take 1/9 into 0.1. Okay? So if I look at this, I'm going to take 9 into 1.0. 9 into 1 doesn't do it. Can't do it. So I'm going to plug in how many times does 9 go into 10? 1 time. Subtract. 10 minus 9 is 1. Bring down the 0. 9. Oh my goodness. Does anybody see a pattern developing? Yes. There is a pattern. It is 0.1 repeating. So I know that instead of 1/9, it's 0.1 repeating. So now I have 0.111111111. I think that was 1. Okay, and then we have 0.1000000000000000000. Okay, remember there's an infinite number of zeros behind this 1. So which one is larger? 0.1 repeating. So we have our first greater than symbol. All right, so here's the next one. Try to figure this one out on your own. Pause now, give it a shot. All right, so if I look at this, I am looking at my 4s first. My 4s are going to be what I look at first because those are equal. Now I move to the fractions. Okay, so 2/9 and 3/5. Okay, I'm gonna get a common denominator of 45. All right, because I multiplied by 5 here, multiplied by 9 here. I get 27 on the right, 10 on the left. Which one is larger? The 27/45, which leads to the 4 3/5. 4 3/5. Okay. So if you look at that, I looked at my whole numbers, brought it down to my fractions, made sure I had a common denominator with my fractions, and then I kept moving. Try these two on your own, and then I will explain. So pause now, give these two a shot. All right, so if I look at this, again, I can go either way. I could take the decimal and make it into a fraction, or I could take a fraction into a decimal. In my mind, the way my mind works, it is easier to take the fraction into the decimal. So how I do that, again, 5 into 4. How many times 5 go into 4? Can't do it. Put my decimals up. 5 into 40, 8 times. And I get 0. Now it's a negative divided by a positive, so my answer is a negative 0.8. So I have a negative 0.80 and a negative 0.8. How do those relate? Equal. They are equal to each other. Don't forget, behind this decimal is an infinite number of zeros. 0, 0, 0. Same thing behind this one. Infinite number of zeros. They are the same. Next, again, 5, 6, and 0.8. I need to get them in the same form. Same form to compare them. So, 5, 6, 0.8, 6 into 5. Can't do it. 6 into 50. How many times? 8 times. 8 times 6 is 48. 8 times 6 is 48. 6 times 8 is 48. How many times does 6 go into 20? Remember, I just added that 0 because there's an infinite number of zeros. 6 go into 20. 3 times. 18 minus 2. Bring down the 0. I see a pattern. Pattern's going to be happening. Okay, so when I notice that pattern, what do I put? I put my bar, so I have 0.83 repeating. 0.8. Which one is larger? Well, 0.83 repeating is 3's are repeating. 0.8 is just zeros are repeating. Again, 0, 0, 0, 0, 0, 0, 0, 0, 0, 3, 3, 3, 3, 3, 3, 3. Which one's bigger? 0.83 repeating. Okay, you need to get them in the same form. Once you get them in the same form, you're able to answer the problem. All right? All right. Okay, we talked. Last note of the day. Okay, all I want you to do is you don't have to write down this entire thing. Just write down these 4 numbers. Those 4 numbers. I'll make it a little easier on you today because I'm feeling nice. I'm feeling generous. Make it those. Write down those 4. Then compare all 4 of them. Compare all 4 of them. Okay? So pause now. Compare. All right. So if I look at this, notice I have 3 decimals and I have 1 fraction. So what's the easiest way to do this? Well, to make that fraction into a decimal. That would just be easiest for me. So when I do that 14/4, I'm going to take 4 into 14. How many times 4 are in 14? 3 times. 3 times 4 is 12. I have a remainder of 2. Does that mean I'm done? No. I need to keep going until I get a remainder of 0. So 0.0, bring down the 0. Put my decimal point on top. 4 into 2. 20 is going to be 5 times. Whoops, not 5 on the bottom. It's 20 down here. Silly Mr. Sheeman. Okay, so 14/4 is 3.5. So now if I look at these, I need to compare these. Okay, think about a number line, which would be farthest to the left on a number line. Farthest to the left, the smallest number. Well, again, negative 3.4. Farthest to the left on my number line. Then, following that would be a negative 2.5. Now I have 3.5 and I have 6.0. Which one's farthest to the left? 3.5 or 6.0? Well, 3.5 is, so because I started off with 14/4, I plugged 14/4 back in. Even though we know it's 3.5, we just changed it from 14/4 to 3.5 just so we could get them in the same form. So 14/4, that's going to be in my answer, and then 6.0. All right? Awesome. We're finished for the day. That's all I have for you. I hope you have a wonderful day. I hope you enjoy these lessons as much as I did because math is beautiful. Okay, I will see you tomorrow. Have a great day. Bye.